Good day, everybody. It's great to have you back. Okay, so in the course of this program, we'll be having a review of some of the things we had gone over in SS2, which are the topics that I have here. So before I go forward, I'd like to say that you're welcome to SS3, and I would like to encourage you to keep on reading and dedicating your time and then pay attention to some of the topics that you feel you're not really strong in so that you can actually learn what those concepts that are giving you tough time, so that when the wire comes, which we are expecting will be in the next term, you will not be caught unawares on any topic. Like if you already know you have an issue with crash recovery. Oh, when Mr. Mo was teaching this topic, I was not really understanding or I was not paying attention for some reason. Now is the time for you to go over those topics so that you can actually cover those topics and be confident before your exam. This is not the type of exam where you go to with no confidence, just trying to look around to try and get the answer somehow. Best thing you can do for yourself right now is to write out the topics that you know by yourself that you're not confident in. And if possible, get that list to me so that I can help you by every means possible. Okay, so I would like us to start off from where we stopped last term. Some of these concepts I know, others didn't do too well. Just a few people did really well. And so it would be great for us to start from these topics that I've just laid out here. So yes, you can go on to copy this as the things we'll be going over in this term. First will be crash recovery. Next, we'll be going over the parallel and the distributed database systems. We'll be going over networking, computer viruses, computer maintenance, career options. Now, because I'm recording these classes, it may be possible that we cover all of these topics in less time than we hope. So let's see how it goes. And if we do that, we'll go into graphics design and laying out a website. So I'll just throw this out there right now. It's important for you to send me your email. Let's set up a time so that we can have virtual classes. I would like to hear responses, from Bushi. Let me hear people speak back. I want to hear your voices so that I can engage you and carry you along. Okay. Okay. So today we'll be going over crash recovery. When we speak about crash recovery, we're actually speaking about a certain type of destruction that happens to your database. So we've gone over SQL programming. We went to the SQL server. We imputed our data in a database. We created all of those fields and columns and even created multiple tables, different tables in our database. Now, as computer people have it, we always have one issue or another. There's always one virus or some power issue or some virus in your flash, or somebody using your computer and deleting files that you didn't want deleted. And when those issues come up, they tend to put our jobs on the line and to put our integrity on the line. So there are certain mechanisms now that we'll be going over, which are very important for anybody who is going to be managing a database to know and to be aware of. Okay, so a crash ideally happens when your computer doesn't have enough memory to perform an instruction. And because there's not enough memory, the computer fails to perform that instruction and tries to recall what the instruction was in the first place. Now we can go on to try to recall that instruction for as long as even a year without being able to remember what that instruction is if there's no mechanism put in place. So the computer will just boot, it will try to execute the program, it will fail to recall what the program is, it will ask itself to reboot, it will come up again, try to execute the program, fail, and then reboot again, and the cycle just continues. That is what a crash is like. Now, if your database crashes, what are the ways ICT people would retrieve their data? Now, mechanisms have been put in place to ensure that you don't lose your data forever, so that you can be sure that your system is always available for others to use. Imagine you were having or hosting an election on Beavers and the computer or the systems crashed. Would you just go and tell people that you don't know who is the winner or you don't know what to do? You really have to think about tough situations like that, and that's why ARIES evolved. Okay, so first of all, what is ARIES? ARIES is a crash recovery mechanism. ARIES actually uses a certain algorithm that is a series of steps to ensure that the data you have saved or typed is not lost forever. And ARIES, as we have it here, ARIES, is used as an international standard for making sure that the database is secured. Okay, so what is ARIES? ARIES actually is created to ensure, once again, that your data is consistent. That is, that if you had saved data by 12 p.m. and a crash happens by 1, all of the data that you had by 12 p.m. will be available once again once you are done with your ARIES process. Also, this happens to databases that are corrupt. Most corrupt databases are as a result of power outages. You're trying to save the database or execute a query. Before the query is actually implemented 100%, the power is interrupted. Now, the computer has no actual record of the last query typed because for some reason it is halfway done. Tries to recover, which is then a crash. Okay. So yeah, Iris uses a algorithm that has 3 steps actually. First, the first step is the write before execution. So it will log the instruction. So in case you want to have a better idea of what this is like, if I want to update, if I want to add, say, Rahima to our database that we have, right, our database table. Before adding Rahima, I had only mentioned Bushi. Okay, so our database table only had Bushi. Now, before adding Rahima, this database protocol would go on to write that I wanted to add Rahima. After it has written that down, then it will actually go on to try to add Rahima to the database. Now, if something goes wrong while I'm adding Rahima to the database, this is great because it always has that log of where Rahima's name was to be added, and that's called a dirty table. It will have a dirty table, and that dirty table will have a log sequence number, is a number, a record number on the table before she was added. So this is great. Like I said, if the computer crashes while I'm trying to add Rahima, I can always go to the log sequence number, LSN, see the right ahead log of what I was trying to do. And then it will also tell me if the transaction was complete or if it was not committed. If it was not committed, then I'll know. It will just have that Bushi was committed, Rahima not committed. And that way I can easily tell, oh, I had done this and I had done this, and this is where the issue was. And that is really great. The next phase of the iris is the redo process. While it goes through this log ahead logs, it will then see all of the committed transactions and it will try to redo any of the transactions that were not committed. So Rahima that was not done in this next phase will be executed again. Okay, so now we've understood the 2 phases. Before I explain the third phase, I want us to imagine that the problem was that Rahima's record was not complete. Let's say her class was not there, her age was not there. And because of that, the system crashed because it was trying to add Rahima to a table and her information was not complete. So now what happens is when it goes to the log table, we can then see that Rahima's transaction was not completed and why it was not completed. And if it tries to do that again and crashes again in the third phase, instead of doing that, it will undo and take us to the last stable state, being where Bushi's name is. And then it will then tell us Rahima's input failed at undo stage. Why did it fail at undo? Because it was not able to do it, so it was undone in order to avoid a crash. If you understood all that I'm saying, that's great. But then if you didn't understand, please feel free to send me a message through my email, which I'm sure everybody has by now. Okay, so it's very important, like I said, for us to be able to go forward to log an instruction before we execute it, to redo all of the things that were done before the crash so that you come back at least to your last checkpoint, or to undo all of the things that will likely bring up another crash so that you have a stable system. This is what ARIES is all about. Log or write ahead protocol, which is writing on a log before you do it, redo all of the things that were not committed, and then undo any of the things that may likely bring issues in the future. Now, you see, this mechanism is so great because if you think about it, nothing can then go wrong if you have a log of everything that was tried. You can see what had failed. You can redo all the things that had failed. And then if they still fail, you always have the undo option to undo what failed. And you will also be able to reference the log sequence number for what had failed, just implement it again and just redo it again. That way you can be sure that your database will always be available and you can always have a consistent uh, piece of data, where you don't really have to roll back so far away, or you don't have to be too scared of having corrupt data. All right, so it's great to know that my students know what ARIES is, how important it is to have data integrity implemented in a system, how important it is to have your system being available at all times, what it means to have a checkpoint while logging, what it means to have a recovery point if the system crashes, and what the ARIES algorithm is all about and how it can be used to improve your database. I look forward to speaking to you next about parallel and distributed databases. See you next time.